Today, we're going to have a quick look at how to work out the variance and standard deviation from a table. To do this, you first should be quite comfortable finding the variance and standard deviation from a normal set of data. Okay, here's our first table. You may want to pause and copy this down for notes. Right. Let's remember, first of all, that our phrase to find the variance is mean of the squares subtract the square of the mean. Let's deal with the first part first, the mean of the squares. So here's our table. We need to add on some extra columns, as is normally the case. So the mean of the squares, they are some terrible lines. Well, here's the squares. We're going to square our column here. So we're going to square our data, so x squared. And x squared is going to give us, well, 35 squared, as you all know, is 1,225. 36 squared is 1,296. 37 squared is 1,369. 38 squared is 1,444. Easy on that one. 39 squared, 1,521. So you need to find the mean of this data. Now, normally, remember from our tables, we would normally do your data times the frequency divided by the total number of pieces of information. So in this scenario though, rather than the data times the frequency, we got our x squared times the frequency. So you're doing f times x squared. So 3 times 1,225, 3,675, 17 times this, 0, 3, 2, 29 times that one, 39701, 34 times that, 49096, and this times this, 39546. Right, let's find out what this all adds up to. Just type it into my calculator. Gives us 154050. Right, so the mean of the squares. These are the total of all our squares. So we're doing the sum of fx squared, which is divided by how many bits of data there are. So let's just add this all up. 109. So divided by the total of the f column. So we'll be doing 154050 divided by 109. So that's our first part. Now to find the square of the mean. This goes back to your work from tables normally. So we'll be doing f times x to help find the mean. So it's your basic fx, 3 times 35, 17 times 36, 29 times 37, 34 times 38, 26 times 39, and that sums to, I made a mistake copying it down. Oh, I missed out. Oh, there. Oops, so that should be 1014, and that should be 1292. Okay, so the mean for this data is the total of this column divided by the frequency, the total frequency. So you can write this like the sum of all of that divided by our total frequency, which is the sum of your f's, and we're subtracting them. So you kind of write out your formula working backwards almost. subtracting 4096 over 109. We want not just the mean, but the square of the mean. So that needs to be squared. And you type it all in, and you get the variance as 1.20 to 3 significant figures. So the variance is 1.20, and if we square root it, it gives us the standard deviation of 1.09, which suggests all the data be quite close together because there's only a 1.09 standard deviation. And our data, so we're kind of like in this sort of region around our average. Let's look at a marginally, I mean marginally trickier one, and that's where we got group data. Now, if you're quite a confident finder of the mean for group data, it's not really a massive stretch to find the variance and standard deviation. It's more just a case of processing it. Now, yes, it's a pain to process, it's a pain to work out, but remember, this is telling us about the spread of the data, about what's the distribution like? Are these scores for this test really spread out? Are they close together? What's it telling us about this particular class? Now, with group data, find the mean. Because there's no particular number we use, we're going to use the midpoint. It's the best guess we've got. It's kind of the average of those. So the midpoint of this is 10, 30, 50, 70, 90. I'm calling it X, some call it XM, it depends on your preference. Right, the mean of the squares. So this time, rather using this raw data there, we're just using the same as before, almost exactly the same as this, but using the midpoint instead. So now we're going to square our midpoint. 100, 900, 2,500, 4,900, 8,100. And the total of that gorgeous set of numbers, 16,500. That's far too enthusiastic. Right, so that's a total. Not sure why I added those up. Utterly pointless. So that's our midpoints. We multiply our frequency by our midpoints squared. So 0 times 100 is 0. 2 times 900 is 1,800. 4 times 2,500 is 10,000. 4 times this is 19600. 5 times that is 40500, and our total is 71,900. Don't actually need that. So the mean of our squares. Here's the frequency times our squares. There's the total. So we've got the sum of fx squared over the total frequency, which is 15. So we're going to have 71,900 over 15. Subtract the square of the mean. Let's find the mean. By all means, pause it and work it out yourself. You're more than welcome at any point to stop it and have a go, and then just double check with me afterwards. So, we're doing 0 times 10, which is 0, 2 times 30, 60, 4 times 50, 200, 4 times 70, 280, 5 times 90, 450, which is a grand total of 990. This is our frequency times midpoint. So the square of the mean is going to be 990 divided by 15. I want the square of that. So that's going to be subtract the total of fx, so the sum of fx over the total of our frequency, squared, which gives us a variance of 437 and a third. And importantly, our standard deviation, which is the square root of that, which is 20.9. So for this test, our students, well, they actually had an average score, the mean average score of 66, and they kind of spread about 21 either side of that. That's our distribution. Now, what I want you to do is have a go at the second test that these random students sat, and find the mean and standard deviation for this table. Pause it and come back to the answers in a second. Okay, so you should have done a table. You should have found the midpoints. You then should have squared the midpoints, give 100, 900, 2,500, 4,900, 8,100. You then should have multiplied our square numbers by the frequency, which is 0, 800, 0, 1, 4, 7, 0, 0, 81,000, and summed them up, which comes to 97500. So the sum of those over the total frequency, which is again 15 students, and subtract from that the mean. The mean was the frequency times the midpoint, which is 900, which sums to 1,170. So you're going to have the total over the total frequency squared, which gives us, surprisingly, a variance of 416 and a standard deviation, so that's that squared, of just 20.4. This is quite interesting. Compare the two tests. So test one, so well done, got this right, by the way, but let's just kind of look, you've done those calculations, why is it vaguely useful? Well, let's say test one was actually from core 1 was the coordinate geometry test, and the second test was from core 2 coordinate geometry test. These tests were set maybe like sat about 6 weeks apart, and the mean, the mean for coordinate geometry 1, this is our first table, the mean was 66 and a standard deviation of 20.9. Oops, no, hang on, wrong place. 20.9. The core 2 exam was our second table. That had a mean, if you work this out, was 78 and a standard deviation of 20.4. So what's really interesting is the class average has jumped up by 12, actually from the easier to the harder test, supposedly, but the variance, it stays roughly the same, which means the students are roughly spread out the same between the two, except the first exam they were here, and the second exam the same students had all improved together. So all the students improved by roughly the same amount in order that the variance stayed the same. So I looked, if you sort of plotted these out, that might be your first test, so the average is there, kind of spread out. And the second test would have looked pretty identical in the spread of the data, just the fact the whole class improved from 66 to 78. Now, what does this tell you? It might tell you that the whole class, due to the fact that everyone's already done the first coordinate geometry exam, found the second one easy to get to grips with. It might tell you that, in fact, this test was just easier than the first test.